Hello YouTube, just Paul again. Going to go through a new project on the workbench today. It's a complete restoration of a General Electric 18 channel A3-5825B model, which is the twin board. This is very similar to the GE Super Base. I'll just swing you around and show you what we're going to do. Okay, so this is the radio. I've prepared the workbench area for what we are going to do. So the updates on this radio, the most important one is that we removed this troublesome cap. We already have track damage around this area. It's not as bad as some of the more recent ones that I've seen, but I'm still going to have to jumper tracks and do some work around here. Secondly, the goal is to replace the green VCO with a Razor Radio's VCO. This is a triple board designed with an RF shield in the middle. And whilst I'm doing that, I'm going to install a 40 channel CB40 with the 2 LED display. And whilst I'm doing that, because I've got to work on the PLL, I will remove the PLL and do the work on the tracks. I'll install a DIN holder for the O2A chip. The other thing that we're doing on this radio as part of the service is to go through and replace all the capacitors on the top and bottom of the board. So this board needs to be removed, and whilst it's out, I'll be doing all the work on the board. This RF shield is going to be replaced with this one, which I've sanded and given a coat of lacquer. The capacitor stock is ready and to go. The disassembly stage will commence with obviously removing all of the knobs, removing the fascia, all the screws along here, the top and underneath, and putting that aside so that there's no accidental damage to this nice fascia. After I've done that, I'll remove all of the header clips, the screw here, 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 remove the antenna screws at the back, and then these screws here. The top board will pull out, and then I'll desolder the ground cable connecting the top board to the bottom board. When I've done that, I'll come back and show you. Okay, removed all the screws, the fascia, set them aside, covered. All of the parts are in the parts box. Now, it was actually very good that we've started work on this radio, and it's the first time that of all the GEs that I've done, that I've got to a point where I'm able to show you the beginnings of all the damage that happens because of this this capacitor. Now, I'll just put this on a board holder. Okay, here we are under the magnifying glass. Alright, so what we see, this is the back of the board. That is the negative leg, and that is the positive leg. Oh, hang on, no, that's the negative leg, that's the positive leg. Have a look at all of this. This is the beginnings of all the corrosion and acid eating through this whole negative pad. And as I've said to you in other videos, the acid seems to always flow down the negative leg of the capacitor first. So what I need to do is remove all of the damage and start to clean up this area. Now, it started to flow over onto the positive side as well, as you can see here. Alright, so the goal here is to clean this up stop the contamination and then reseal with PCB lacquer. Sorry for this. Okay, so there we go. So I'm just going to clean this with IPA to start with, and there's a bit of work under the magnifying glass, and then I will come back and show you after I've replaced the capacitor. Alright, well, we're back again. I've done a bit of work on the area. As you can see, I'm just about to remove the capacitor. And have a look at this. See all the black corrosion to the point that it's carbonized. I'll get in right in close here. So that's on the positive leg, there's the negative leg. You can see here that the acid's already eaten all the way through this part of the board on this big pad. You can see here. So what I'm going to have to do is create a new pad on top of this out of copper. And probably do a new pad here out of copper as well. Alright, I'll remove all the solder and remove the capacitor. Alright, the capacitor's removed. As you can see on the top surface there, you can see where the capacitor was, and you can see some of the damage, which means that in this area here, see how it's following along that track? All the way along there. I'm going to have to jumper that. That track will just dissolve probably over the period of maybe 6 months, 12 months. And then a tiny bit around here as well. And up, it stops around here. Alright, I'll clean that area up and start work. Alright, I've got an example here of what we've found, and the damage is actually already eaten through the tracks. This one here, which I was just uncovering. Okay, now that was just joined. It was eaten all the way through and it was just being held on by a tiny bit here. So that's what you're up against, and it thins the copper out to almost nothing, what goes on here, this process. Alright, so I'll start repairing the tracks. I'm just going to run jumpers and I'll show you when I'm finished. Okay, we're back again. Let's see, the track repairs have been done. I've tested my work. I've seen some absolute shockers on this. I actually should get some green coloured wire, but this wire is the right thickness for this job, and I can't get it from my normal suppliers. Alright, so we've gone from this point here on the, you don't solder these directly to tracks. I've seen them soldered here, I've seen them soldered over here, and what happens over time is as you're moving or working on a board, you peel up the track. So you've always got to take the wires to the through-hole connector and solder to that. And I remove the solder, heat the area up and put fresh solder in. So there's been 2 tracks that we've had to replace, and then the positive rail here, what I do is I run the jumper down to this, separate the wire. I don't break the wire, I separate the sheath, solder it and then drop that on there, and I ran the end of that down to this through-hole connector here. What I will do is I'm going to drop hot melt glue, just a couple of little ones, to seal the cables and stop them from moving around, and then we flip the board over and start on the bottom board repairs. Alright, I've just neatened up the cables, just a couple of dabs of hot melt glue, just making it a neat job, and just positioning the replacement Gemcom cap 1000 UF 16 volt in that hole, just so I can locate underneath. Alright, I've put in one track and I'm about to repair the middle section. So this one's done. This one here, there was nothing left of the track on top of the surface, so it just made sense to remove it, and I started trimming up the edges. And what I'm going to do is trim up around here, expose copper, reflow, so I've got something to bond to when I put down the new tracks. Okay, new copper ground pad put in place. I've made it up out of 3 pieces. The next process is to just expose a tiny bit of copper around the edges, join them all and reflow, and then spray with PCB lacquer. Alright, this repair is done from an electrical perspective. I've just cleaned the area and now I'll just lay some PCB lacquer on the surface. I'll just zoom out and show you the size of this area that we've been working on. Okay. Now that's the proper way. There are better ways of doing this. You can actually, I don't have full sheets of copper, so I make my own tracks out of the copper that I have. So ideally I'd have a full sheet of copper and take a stencil. Alright, so that's the proper way of doing this, and I'll show you the bad way. Alright, this is just one of the jobs that I've had it trying to repair. And if we look up there versus my repair, we look down here, and this is by far not the worst. I've got another one here that will either be parted out or it's going to be put in the too hard basket. Alright, we move on. PCB lacquer. Alright, ground pad is now fixed and sealed and covered in lacquer. Alright, I'm going to conclude this. I've been working on this now for several hours and it's time to put away and then start the doing the VCO, or actually I'll change the VCO and I'll do that now, and also the O2A chip. Okay, desoldered the mounting tabs, or the earth tabs on the VCO, there and there, and then just desoldered these 5 pins. We're now ready to install the Razor Radio's VCO. Okay, soldering done, cleaned up this pin, these 2 pins and this pin, and then just cleaned these areas up here as well, and that job is done. I'll flip it over and show you. Okay, that's the new VCO installed. You can see RR for Razor Radios on his VCO. It's just in behind the 10240 crystal. Let's see, we'll give a comparison for size. So it's around about 70% the size of the original VCO. And for those that are saying that you'll get RF interference, no, this board design is shielded. Ray's gone to much length to create this triple board design, and there is a ground plane in the middle of the sandwich between one of the 3 layers. And on the scope, it's actually very, very clean, this VCO, and it's as good as, if not better than, the mid-1970s technology. Alright, I'll just replace the O2A and put the chip holder in. Okay, this is a before shot of the work that's about to be done, and then I'll show you an after shot. Okay, so that's the soldering done on the O2A chip holder. So the PLL O2A was removed and then the chip holder put in. I'll just flip it over. Okay, chip holder done. We'll insert the O2A back in shortly. Just remember, it's we all do it at some point. There's a little cutout or indentation marking the orientation of the O2A chip. Please make sure that you have it up that end. See that? I did it once. I turned it around the wrong way, and it was on a radio which had a lot of repairs to the underneath. So it was a bit of a challenge to fix the repair, fix the fail, but it all came out fine in the end. Now, just on the O2A side, it's very easy to blow the O2A chip. They don't like heat. So what I do when I remove, I put the soldering iron on low heat, sharp, very pointy nib, 1 mil, just under 1 mil in width, and then I go from side to side, just like doing head bolts on a car engine head, and that way there's no heat getting built up from pin to pin to pin, and you're doing it in a sequence. So I just go opposite, solder, desolder, suck, desolder, suck, and then just backwards and forwards like that. All right, that's the job. I'll put the O2A back in. All right, O2A is back in its spot, sitting in its holder. So the job for tomorrow is to start working on the tracks, cutting those. When I do that, I will be removing the O2A chip, as we can do that now, and I'll put that aside until it's ready to test the CB40. Hope you enjoyed today's video. This is another GE we're bringing back to a long life. Thank you.